In this video, we're going to look at interpolating tie lines on a ternary diagram. And here we have a ternary diagram for three liquids, IPA, water, and ether, at a specific temperature and pressure. And we have our phase equilibrium data here. And we may want to use something like this for a liquid-liquid extraction system in terms of maybe solving for the number of stages or what our compositions may be after mixing two different solutions together. The tie lines we might get from our equilibrium data, but we may need to draw other tie lines. And it's probably not the best thing to do to try to look at the line and gauge on how it should connect between two equilibrium points. So in this video, we're going to show two different ways to use this diagram to create more tie lines. So we're going to start with method 1. So in method 1, we're going to draw parallel lines to the line AB and BC. So I'm going to highlight line AB and draw green lines parallel to that to demonstrate this. And I'll use purple lines for the line BC. So we're going to take any of our tie lines, and a good number of them, so that we could draw what's known as a conjugate curve. So let's start with this first tie line shown here. What we're going to do is draw a green parallel line to the line AB, and then we'll draw a line parallel to the line BC from the other point. And where these intersect, we'll draw a point. And we're going to repeat this process for each of our tie lines. So here I show our second tie line, which I'm going to highlight yellow. And we've drawn two parallel lines. We're going to mark that point. And then we'll do this again for the next one. Draw a point where those intersect. And we could continue with more tie lines that we have if we wanted to. I'm more interested in drawing an interpolated line between the three I've just chosen. The point that we're missing here is what's known as the Platt point, where the compositions of the raffinate and the extract are equal. Now, we're not told what point that is, but we could estimate that it's going to be somewhere around here. So as you can see, this is going to be a curve. We have to do the best we can at matching these points up along that curve. So now we want to draw more tie lines. So we choose anywhere on that curve and then just reverse the process. So for instance, I could pick right between two of our points, and I'll draw a parallel line to our equilibrium curve, and draw another parallel line to our other equilibrium curve. You can see where these two lines meet on the equilibrium curve, so we'll connect those 2 points, and now you see we have another tie line. So we can do this again, and where those two lines meet, we'll draw another tie line. And so you can see that based on this conjugate curve that we've made, which I'll now delete, we've interpolated the tie lines we might have had from data and created more that we could use to read from our plot. So again, this is what we're going to say is method 1, and this is using the lengths AB and the other side BC. So let me show you method 2. So in method 2, we're going to use two different sides. We're going to use AB again, but this time we're going to use AC. So our intersection is going to actually occur within our triangle. And this method's used less just because it can get a little cluttered. So this time I'm going to highlight side AC blue. So the first thing we'll do is choose our Platt point again. And we'll choose our tie lines. So here I'm going to choose our first tie line, and we're going to draw parallel to length AC. Now we're going to take our other tie line point and draw parallel to AB. And where these intersect, we're going to put a point. And we repeat this for each of the tie lines, just like we did in method 1. So here I've chosen 3 tie lines from our plot and draw the intersection of these 3 lines. So you can see our curve is going to be within the diagram. And again, from here, we use our conjugate curve and reverse the process. So I could choose anywhere along that curve and again draw lines parallel to the lengths that we started with. So for instance, here's one point along the curve that we've drawn 2 parallel lines, and where those intersect on our equilibrium graph is where we're going to draw our new tie line. So we could repeat this process for as many tie lines as we want, and we could create that. And again, as you see, since it's inside our triangle, this can get kind of cluttered. So hopefully these two methods show you how we can interpolate tie lines in our phase equilibrium diagram, and we could use this maybe later in a liquid-liquid extraction problem where we need more tie lines to solve the problem, or maybe we're looking for compositions from our mixture and it helps to be able to read right off a tie line.